This is SpaceTime, Series 20, Episode 78, coming up on SpaceTime. Narrowing down on dark energy, discovery of a strange comet-like binary asteroid, and Russia to join the United States, Europe and Japan to build the Deep Space Gateway lunar space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study looking at pressure waves generated in the primordial universe has revealed possible evidence of dynamical dark energy. The potential discovery, reported in the journal Nature Astronomy, means dark energy could behave differently to the cosmological constant model first proposed by Albert Einstein 100 years ago. Dark energy's become a sort of catch-all term, used to explain the apparent accelerating expansion of the universe out from the Big Bang 13.8 billion years ago. There are numerous hypotheses to try and explain it, some more accepted than others. Professor Albert Einstein first came up with the idea to explain a problem he was having when he applied his famous 1915 equations of general relativity theory to the cosmology of the whole universe. Like other scientists of the day, Einstein believed the universe was in a steady, unchanging state. Yet when applied to cosmology, his equations were showing the universe wanted to either expand or contract as matter interacts with the fabric of space-time. As Dr. Einstein put it, matter tells space-time how to curve, and space-time tells matter how to move. To resolve the problem, Einstein introduced a dark energy effect in 1917, which he called the cosmological constant. It was a purely mathematical invention, a fudge factor, designed to resolve discrepancies between general relativity theory and the best observational evidence of the day, in the process bringing the universe back into a steady state as it should be. However, years later, when astronomer Edwin Hubble discovered that galaxies appear to be moving away from each other, and that the rate at which they were moving away was proportional to their distance, Einstein realized his mistake, describing the cosmological constant as his biggest blunder. However, the idea of a cosmological constant has never really gone away, and it keeps reappearing to explain strange observations. The issue came to a head in the mid-1990s, when two teams of scientists, one led by Brian Schmidt and Adam Rees, and the other by Saul Perlmutter, independently measured distances to Type 1a supernovae in the early universe, finding they appear to be further away than what they should be if the universe's rate of expansion was constant. The observations led to the hypothesis that some sort of dark energy anti-gravitational force must have caused the expansion of the universe to accelerate over the past 6 billion years. The new study's lead author, Professor Gongbo Zhao from the University of Portsmouth and the National Astronomical Observatories of China, says his observations are pointing towards a dynamical model of dark energy, rather than the traditional lambda cold dark energy model using vacuum energy, which is based on Einstein's cosmological constant, which has no dynamical features. The physical property of dark energy is represented by its equation of state, which is the ratio of pressure and energy density of dark energy. The traditional lambda cold dark matter model has a constant equation of state of -1. Zhao and colleagues performed high-precision measurements of the baryonic acoustic oscillations at multiple epochs using data from the Sloan Digital Sky Survey 3 BOSS collaboration. Baryonic acoustic oscillations are regular periodic fluctuations in the density of the visible baryonic or normal matter in the universe. They were imprinted into the fabric of space-time during the cosmos's early history. The authors believe their new measurements could be evidence of a dynamical dark energy with a level of significance of 3.5 sigma. Now, if supported by further evidence, it would suggest that the nature of dark energy may not be the long hypothesized lambda cold dark matter model, but instead some kind of dynamical scalar field whose equation of state varies with time and crosses the -1 boundary during evolution. Zhao bases his model on the quantum scenario for dark energy, which uses the quintessence and phantom energy hypotheses as a basis for dark energy. Zhao and colleagues are now waiting for the next generation of astronomical surveys, such as the upcoming Dark Energy Spectroscopic Instrument, or DESI survey, in order to explore these observations in more detail. DESI will begin creating its three-dimensional cosmic map next year. In the next 5 to 10 years, the world's largest galaxy surveys will provide observables which may finally provide the key to unravelling the mystery of dark energy. You're listening to SpaceTime. I'm Stuart Gary. A strange comet-like asteroid first discovered more than a decade ago has turned out to actually consist of two asteroids orbiting each other. The findings reported in the journal Nature represent the first known binary asteroid also classified as a comet. The binary, named 2006 VW139-288P, was initially discovered by the University of Arizona's Spacewatch program in 2006. It was observed lurking in the main asteroid belt between Mars and Jupiter. The binary asteroid's comet-like activity was first noticed in Hawaii Pan-STARRS data in 2011 as it approached perihelion, its closest orbital position to the Sun. Then, in September 2016, astronomers took a more detailed look using the Hubble Space Telescope. The new images reveal that 88P is actually composed of two asteroids of almost the same mass and size, orbiting each other at a distance of about 100 kilometres. Knowing their orbital distance from each other allowed astronomers to determine their mass. The new Hubble images also confirmed ongoing activity in the binary system, with a bright comet-like coma of material surrounding the asteroids and streaming into a long comet-like tail. Initially, the binary asteroid's tail was producing relatively large 1 mm diameter dust particles. However, by September 20, the tail began pointing away from the Sun just like a comet, and smaller 10-micron wide particles were being blown away from the nucleus. Like any object circling the Sun, 288P travels along an elliptical path, bringing it closer in and further away from the Sun during the course of its orbital year. About 20 so-called active asteroids similar to 288P have been discovered, although so far this is the only binary system. It's thought when these objects collide, volatiles previously buried deep inside are exposed and begin to outgas, producing the comet-like features. In the case of 288P, the outgassing caused a rotational spin-up, resulting in the asteroid splitting apart. The authors detected strong indications of the sublimation of water ice due to increased solar heating, similar to how the tails of comets are created. It's this which makes 288P the first known binary asteroid that's also classified as a main-belt comet. Understanding the origin and evolution of main-belt comets, that is, asteroids orbiting between Mars and Jupiter that show comet-like activity, will help scientists trying to understand the formation of the solar system as a whole. The high-resolution Hubble images will help researchers constrain hypotheses on the processes at work deep inside these active asteroids. The various features of 288P, wide separation of the two components, near equal component size, high eccentricity and comet-like activity also make it unique among the few known wide asteroid binaries in the solar system. The observed activity of 288P also reveals information about its past. Since surface ices can't survive in the asteroid belt for the age of the solar system, but can be protected for billions of years if they're coated in a refractory dust mantle a few metres thick. As it's still so active, the authors think 288P's probably only existed as a binary for a short period of time, maybe only 5,000 years. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Let's talk about Hubble finding this mystery object in our solar system, and I reckon it's a rock.
Well, you might be right or you might be wrong.
I can be both.
We don't know. What they found, you're right, it's in the asteroid belt. So this is the place where we know there are millions of asteroids. It's that region between the orbits of Mars and Jupiter where the kind of debris of the solar system has collected. It's one of two places where it's collected in big time, and the other one is way out beyond the orbit of Neptune. So we've got this object which has been observed by the Hubble, and it has two features that make it unusual, possibly even unique. First of all, it is what's called a binary asteroid. So it's thought to be an asteroid. In fact, it's classified as an asteroid. It's got the marvelous name of 288P, which you would know immediately tells you that that's an asteroid.
Absolutely, yep. Got it. No.
288P is made of two objects which are in orbit around one another. So any circumstance in which we get two things orbiting each other is called a binary. And for example, we get binary stars. We have a binary dwarf planet out there in the depths of the solar system. That's Pluto and its big moon Charon, because they orbit each other rather than Charon orbiting Pluto. But this 288P is a binary asteroid. It's two halves which are in orbit around one another. But the thing that makes it possibly unique is that the two objects are showing characteristics of a comet.
Oh.
And what happens with comets is that they are made, unlike asteroids, which are rocky or stony, comets are made largely of ice. And when the sun's radiation hits their surface, that ice, actually, it doesn't evaporate. It goes through a process we call sublimation. It sublimes, which means it goes straight from a solid to a vapor. And it's that vapor that we see illuminated by sunlight. It causes it to glow. And so this pair of so-called asteroids have what's called the coma, the sort of region of glowing around the asteroid, and a tail as well, driven off by the radiation of the sun in the opposite direction to the sun, which is exactly what happens with a comet. So this thing is part comet, part asteroid, and part binary.
It's a cometoid.
It could be a cometoid. Yeah, that's a great name. Yeah. I think you should write in and suggest that. Cometoid 288P. That's got a ring to it. Yes,
we're doing well with names today.
I think we're doing really well. It's a team from. I'll just move on. A team from Germany, from one of the Max Planck Institutes in Germany, who have made this discovery. And I think because it is so unusual that the two halves of the binary are very widely separated. They're almost equal in size. They have what we call a high eccentricity, so they're not orbiting one another in circles. They're going in very elliptical orbits, elongated orbits. So it is very, very odd.
It is.
And apparently the research team have realized, or they believe, that this has been a binary system, in other words, two objects together, for only about 5,000 years. That suggests that these things came together, or maybe something broke up due to fast rotation, or two separate things came together. It seems unusual that would have happened, to have two comet-like objects coming together by accident. So maybe a breakup scenario is the one to go for.
So they'll obviously study this more closely to see if they can define it, because if it's something they've never seen before, then obviously it warrants further investigation.
Absolutely. Yeah, I'm sure there will be a lot of research done on this. When you find unusual objects like this, particularly in the solar system, which is our cosmic doorstep, yes, people get very excited, which is why I'm excited, Andrew.
Yeah, well, it's your job. No, it's fascinating. So we'll probably hear more about this down the track. Do we know where it's headed? Is it going to the sun?
It is just in orbit. It does have an elongated orbit, but mostly within that region between Mars and Jupiter. So it's not going to, like comets, which are in very elongated orbits, it's not going to get near the sun and start brightening up. It will pretty well stay in the neck of the woods where it already is.
That's Dr. Fred Watson from the Australian Astronomical Observatory, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. New evidence supports the idea that the Great Permian Mass Extinction event 250 million years ago was caused by the huge megavolcanic eruptions of the Siberian Trap. Known as the Great Dying, the Permian Mass Extinction event killed over 90% of all species on Earth. The findings in the journal Scientific Reports claims the mega eruptions triggered significant environmental changes, leading to the end of most life on Earth. The authors based their new findings on a global spike in the element nickel, which they discovered occurred at the exact time of the mass extinction. They say the nickel most likely came from the huge Siberian Trap volcanic mega-eruptions. The Siberian Traps form a large region of volcanic rock known as a large igneous province in Siberia, Russia. The massive eruptive event which formed the traps is one of the largest known volcanic events in the last 500 million years of Earth's geological history. The eruption continued for over 1 million years, spanning the Permian-Triassic boundary about 251 to 250 million years ago, as the Earth's crust literally split open. The term traps is derived from the Swedish word for stairs, trappa or sometimes trepp, referring to the step-like hills forming the landscape of the region, which is typical of flood basalts. These eruptions are associated with nickel-rich magmatic intrusions, rocks formed from the cooling of magma that contain some of the greatest deposits of nickel ore on the planet. The authors used an inductively coupled plasma mass spectrometer which measures the abundance of rare elements at their atomic level. They found anomalous peaks in nickel ranging from regions as far north as the Arctic to as far south as India at the time of the Great Permian Mass Extinction event. The study's lead author, Michael Rampino from New York University, says the Siberian volcanic eruptions and related massive intrusions of nickel-rich magmas into the Earth's crust also emitted nickel-rich volatiles into the atmosphere, which were then globally distributed. The mega-eruptions produced intense global warming and other environmental changes, which all combined to lead to the Great Dying Mass Extinction. At the same time, explosive interactions of the magma with older coal deposits could have released large amounts of carbon dioxide and methane, two greenhouse gases, which would explain the intense global warming recorded both in the oceans and on land at the time of the mass extinctions. The warm oceans would have become sluggish and depleted in oxygen, contributing to the extinction of most forms of life in the sea. You're listening to Space Time. I'm Stuart Gary. Russia has agreed to work with the United States, Europe and Japan in developing the DSG, or Deep Space Gateway, a new space station to be built near the Moon. The Deep Space Gateway will be constructed in a near-rectilinear halo orbit, which is a Lagrangian point between the Earth and the Moon, where the gravity of both celestial bodies balances out, allowing an object to remain in position orbiting around the Earth in concert with the Moon. The new outpost will be a stepping stone beyond the low Earth orbit International Space Station, allowing scientists to test and develop technologies and capabilities needed to support human missions exploring Mars and further out in the solar system. The station would also be used as a staging point for missions to the lunar surface. Most importantly, it'll also allow quick return to Earth in just a matter of days in the event of an emergency. DSG spaceport construction is slated to begin in the mid-2020s using NASA's new Orion spacecraft and SLS heavy lift launch system. The Russian space agency Roscosmos announced its cooperation in the project at the World Astronautical Congress in Adelaide. At this stage, the various components are slated to be launched aboard the SLS as Orion co-manifested payloads over at least 7 flights. Russia, however, have already hinted they'd like to use their own heavy lift rockets, the Proton M and the Angara A5M, as part of the construction schedule. The core module, to be known as the Gateway Power and Propulsion Bus, will have a mass of about 9,000 kilograms and will be capable of generating all the station's power needs through its solar panels. It'll also be equipped with xenon-ion thrusters to provide manoeuvrability, backed up by conventional chemical propulsion systems. The module will be sent during NASA's Exploration Mission 2. The next module to fly will be the Cislunar Habitation Module, which will be used for long-duration crew habitation aboard the space station. It'll be sent during Exploration Mission 3. Then there's the Gateway Logistics Module. It'll be a science lab used for experiments and logistics aboard the space station. Equipment fitted to the module will include a Canadian Space Agency-built robotic arm. It'll be delivered during Exploration Mission 4. The fourth of the initial modules, to be known as the Gateway Airlock Module, will be used for performing extravehicular activities, or EVAs, spacewalk in NASA speak, and it will be sent during Exploration Mission 5. However, as we saw with the construction of the International Space Station, those targets are bound to change. I'm Stuart Gary. You're listening to Space Time. The 2017 Nobel Prize in Physics has been awarded to Professors Barry Brush, Kip Thorne and Rainier Weiss for their groundbreaking work to detect gravitational waves. The discovery by Advanced LIGO, the Laser Interferometer Gravitational Wave Observatory, was further proof of the predictions emanating from Albert Einstein's 1915 general theory of relativity. The team were able to observe for the first time ever gravitational waves generated by the cataclysmic collision of two black holes 1.3 billion light-years away. The international team have detected at least 3 more gravitational waves involving merging black holes since that historic first detection back in September 2015. The technique has effectively opened a window on a new age of astronomy and physics, allowing scientists to probe the nature of black holes, neutron stars, supernovae, and other celestial events, some of which may not yet have been even dreamed of. Thorne and Weiss were the founders and architects of LIGO, with Brash bringing it into fruition. LIGO is operated by Caltech and MIT, with funding from the National Science Foundation and supported by input from more than 1,000 researchers globally, including several teams from Australia. Gravitational waves are ripples causing the very fabric of space-time to alternately expand and contract by less than the diameter of a proton. They're caused by massive cosmic events, such as the mergers of black holes or neutron stars, or the cataclysmic explosion of supernovae. They provide a new way to look at the universe. Up until now, astronomers and physicists have dealt with the universe primarily through electromagnetic radiation, or through physical particles like neutrinos and cosmic rays. Gravitational waves remained undetectable until the technological breakthroughs at LIGO. The waves carry unique information about the origins of our universe, and studying them is expected to provide important insights into the evolution of stars, supernovae, gamma-ray bursts, neutron stars, and black holes. Meanwhile, the Nobel Prize in Chemistry was awarded to Jacques Dubochet, Joachim Franks, and Richard Henderson. Their work made it possible to see biomolecules in 3 dimensions after rapidly freezing them to around minus 150 degrees Celsius while preserving their natural shape. It was this work which helped scientists observe the structure of the Zika virus. And the Nobel Prize for Medicine and Physiology was awarded to Jeffrey Hall, Michael Robash and Michael Young for their work towards understanding the molecular mechanisms controlling circadian rhythms. Circadian rhythms are the body's inner clock, helping to regulate sleeping patterns, feeding behaviour, hormone release and blood pressure. You're listening to Space Time. I'm Stuart Gary. It's been a busy week for space in Australia, especially following the Astronautical Congress in Adelaide. Among the highlights, other than the long overdue announcement of the formation of the Australian Space Agency, Congress also saw announcements that the University of New South Wales has won a contract to build 3 CubeSats for the Australian Air Force. The 3 will be used on 2 low Earth orbit space missions. One of those missions will take up maritime surveillance, and the other will help protect Australian space assets from orbital debris. The first mission will launch early next year, followed by the second in 2019. Meanwhile, the CSIRO and the Australian National University's Mount Stromlo Observatory have announced plans to develop enhanced sensor and onboard data processing capabilities for Defence Department drones and satellites. The project will include using simultaneous observations of light to build 3-dimensional models of the sea. The models will be key in peeling back layers of the ocean to literally see beneath the surface. Initially, the focus will be on the land-to-sea boundary, using sophisticated models to determine important properties such as underwater visibility, the structure of the seafloor, and the local flora, such as seagrass, coral coverage, and its health. The project will focus on developing a single sensor design capable of being tuned to address remote sensing problems as diverse as detecting submerged objects and assessing coral reef health in a single package. Meanwhile, the University of Sydney has signed a new deal with Germany's National Space Agency DLR to build a new multispectral Earth resources satellite. The 150-kilogram Earth observation satellite will be known as the Multispectral Satellite for Australia and Deutschland, or MISAD. MISAD will use multispectral cameras to monitor the land surface, capturing details of agricultural and environmental conditions. The cameras will also be optimised to monitor water quality in rivers, lakes and dams to detect algal blooms such as that threatening the inland water supply of the Murray-Darling Basin. MISAD would also carry a highly sensitive infrared camera, allowing firefighters to localise wildfires from space down to just a few metres. You're listening to Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Major Australian cities such as Sydney and Melbourne will be experiencing summer temperatures of over 50 degrees Celsius within a few years because of human-induced global warming. That's the warning from a new climate study by the Australian National University, which looked at the likely impact of global warming under the Paris Agreement's global warming limit of 1.5 to 2 degrees above pre-industrial levels. The new climate modelling has projected daily temperatures of up to 3.8 degrees Celsius above existing records, and that's despite the ambitious Paris efforts to curb global warming. In fact, Sydney has just experienced both its driest and warmest winter on record, and there was virtually no rain recorded in Sydney during the month of September. The new study reported in the journal Geophysical Research Letters found that 2015, one of the hottest years on record globally, is likely to wind up being a fairly average year by 2025 standards. A new study has found that gay and bisexual men making less than $30,000 a year and without a university degree have more than 5 times the odds of attempting suicide compared to their more affluent peers. The findings by scientists with the University of British Columbia is the first Canadian study to analyse how socioeconomic factors like income and education are associated with suicide risks among these men. Researchers also found that bisexual men who were in a relationship with women were less likely to attempt suicide compared to those who were single or those who had male partners. The study found for bisexual men having a female partner was protective because it shields them from the stresses and discrimination of being a member of a visible and victimised minority. Scientists evaluated data from the National Health Survey of 8,382 men who have sex with other men. The analysis then focused on men who reported having attempted suicide in the past 12 months. The study found that the number of gay and bisexual men who die by suicide is comparable to those who die from HIV/AIDS. Yet little is known about the contributing factors, especially how social factors and suicidal behaviours intersect. Researchers have discovered that kids who are bullied at school have a far higher risk of developing mental health problems. The study, reported in the journal JAMA Psychiatry, found that being bullied at 11 years of age contributes to mental health problems such as anxiety, depression, hyperactivity, inattention, and behavioural problems. The findings are based on a survey of 11,108 twins who were all 11 years old. The kids were then surveyed again at the age of 16 to see what the effects of different levels of bullying was on children who had the same environments and similar or identical sets of genes. The authors suggest that work not only needs to be done to stamp out bullying, but also greater effort needs to be placed in supporting the victims of bullying. Australian researchers have been startling young crocodiles in order to find out how rising temperatures affects the way they hide from predators. The study, reported in the journal Experimental Biology, found that when frightened, young crocs dive and remain submerged until the threat passes. The researchers suspected that the cold-blooded reptiles would resurface sooner in warmer water because their metabolism would be burning through oxygen faster. They found that when startled, crocs in 34 degrees Celsius water remain submerged for just half the time as crocs in 28 degrees Celsius water. The findings suggest that younger crocodiles will become more vulnerable as the climate heats up due to global warming. Well, following this week's news of measles outbreaks in New South Wales and Victoria, a new study reports that the impact of unscientific claims by anti-vaxxers is being blamed for a recent increase in measles cases across the United States. The findings, reported in the Journal of the American Medical Association, found that not getting vaccinated could be the main cause of the recent jump in measles across the United States. The researchers looked at all 1,789 records of measles in the United States between 2001 and 2015. They found that 7 in 10 of those cases involved people who hadn't been vaccinated. The authors say the decline in numbers of vaccinated people getting the disease suggests that people not getting vaccinated is the main driver behind the recent rise in measles. The Australian mining company Rio Tinto has commenced operating its first fully autonomous unmanned iron ore trains. The trains are operating over a 100-kilometre section of track through the Western Australia Pilbara region. The successful runs mark the first step in the company's plans to develop a fully autonomous railroad network by 2018. Of course, these aren't the first driverless trains in the world. Driverless passenger trains, especially rapid transit systems, have become commonplace ever since they were first introduced on the London Underground's Victoria line in 1967. In fact, Rio Tinto isn't even the first automated freight train operation. That honour goes to the Black Mesa and Lake Powell Railroad, which opened in northern Arizona in 1974 as an automated driverless operation. However, the railroads of the Australian Pilbara do hold records for running the world's longest and heaviest trains. BHP Billiton have regularly operated trains of 336 wagons, over 3 kilometres in length, carrying some 44,500 tonnes of iron ore, hauled by between 6 and 8 4,400 horsepower locomotives. The company also holds the current world record for running a 7.3 kilometre long train containing some 682 wagons. The train, which weighed a colossal 99,734 tonnes, was hauled by 8 6,000 horsepower locomotives. And finally for now, October the 4th was World Animal Day. It's celebrated on St. Francis of Assisi's Saint's Day. To mark the occasion, a new study's been released showing that some 62% of Australian households have pets, one of the highest rates of pet ownership in the world. The study found that 38% of households have dogs, 29% have cats, 12% keep birds, another 12% keep fish, and 3% keep reptiles. Having a pet has been shown to have positive health benefits, including a reduction in childhood allergies. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Audio Boom, YouTube, from spacetimewithstuartgary.com, or from your favourite podcast download provider. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. If you want more Spacetime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one worded in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @Spacetime with Stuart Gary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.